In the name of Allah, the Beneficent, the Merciful. Welcome to the world of physics. Due to coronavirus, we have to continue our online class. At first, I'd like to suggest you to stay home, stay safe. Let me introduce. I am Mohammad Muqtadir Hossain Bhuiya, lecturer, Department of Physics. At first, observe this diagram, and you may take 5 to 10 second time to observe this diagram. And here some information is shown for you. At first, we see that initial amount is 100%. After first of life, the amount is 50% remaining, and graphical presentation of the information is shown here. By observing all this diagram, we can guess the name of the chapter. Yeah, the name of the chapter is Atomic Model and Nuclear Physics, and today we are going to solve mathematical problems based on this chapter. After the end of this lesson, you will be able to write necessary equation of this chapter, and you can solve mathematical problems of this chapter. Here the necessary equation like n equal to n naught e to the power minus lambda t, n naught is equal to n t divided by 2 to the power minus lambda t, or t half is equal to t ln 2 divided by ln n by n naught, and t is equal to ln n naught over nt over n naught divided by minus lambda. These are the equation, necessary equation, and here t is elapsed time, t half is half life, and n naught is beginning amount, and t is ending amount. And we know lambda is the decay constant, and lambda is equal to ln 2 divided by t half. And derivation of the relationship between half-life constant, here we have some constant like we are going to derive the relation between t half, tau, and lambda. And at first we have equation that is half to the power t half over t over t half is equal to e to the power minus t over tau and e to the power minus lambda t. And after that we can write we take ln in all side, and then after calculation we can write the equation as t half is equal to tau ln 2 is equal to ln 2 divided by lambda. This is the relation among t half, tau, and lambda. And here the decay law is n is equal to n naught e to the power minus lambda t. And here number 3 equation is very much known to you, and in our textbook we learn about the equation number 3, and both number equation 1 and 2 is similarly correct, and you can solve any mathematical problem by any of the equation. These are the equivalent equations. Here n naught is the initial quantity, and nt is the remaining quantity, and t half is the half-life, and tau is the mean life, and lambda is the decay constant. And before going mathematical problems, we are going to discuss some glossary of this chapter, and these are Becquerel, half-life, and radioactive dating. And here Becquerel is the SI unit of rate of decay of a radioactive material, and half-life is the time in which there is a 50% of the chance that a nucleus will decay. And radioactive dating, an application of radioactive decay in which the age of a material is determined by the amount of radioactivity of a particular type that occurs. And here some other glossary are decay constant, carbon 14 dating, and activity, rate of decay, and Curie. And here decay constant is the quantity that is inversely proportional to the half-life, and that is used in equation for number of nuclei as a function of time. And here carbon 14 dating is a radioactive dating technique based on the radioactivity of carbon 14, and activity is the rate of the decay of the radioactive nucleus, and rate of decay is the number of radioactive events per unit time. And here Curie is the activity of 1 gram of radium 226 equal to 3.70 into 10 to the power 10 becquerel. And here our number one mathematical problem, and the question is, what will be the frequency of photon emission of an agitated hydrogen atom turns into surface? And here we have equation like E is equal to U minus EL, and U is the upper state and EL is the lower state. And we also know that here we have to calculate frequency. We uh, for calculating frequency, we can put E is equal to HF, and after putting HF, and finally we can write the equation for frequency. And here F is the frequency, and here we have the equation U minus EL divided by H, and here H is the Planck constant, and EL is the lower level or surface level energy, uh, and EU is the upper energy level. And we all know the values of upper energy level and lower energy level, and Planck constant. All the value are known to us, and by putting all this value, we can calculate the value of F, that is frequency of photon emission of an agitated hydrogen. And here for EL the value is 13.6 electron volt, and for U the value is 1.5 minus 1.5 electron volt. And by putting all this value, we can calculate the value of frequency by using this equation. And next problem is when U is 1.5 and EL is minus 3.4 electron volt, find the frequency of the emitted photon. And here the value is given, and we have to calculate frequency, and this is the equation for frequency F, and by putting all this value, we can calculate frequency here. Our next problem is calculate first Bohr orbital radius of the hydrogen atom, and we have to calculate Bohr radius. And uh, we have equation that is a naught is equal to 4 pi epsilon naught h by 2 pi square and divided by uh, mc me square. And here a naught is the Bohr radius, m is the rest mass of the electron, epsilon is the permittivity of the free space, and h by 2 pi is the reduced Planck constant, and c is the velocity of the light in vacuum, and alpha is the fine structure constant, and E is the elementary charge. And by here we see that all these value are constant, and by putting all this constant value, we can get the value of a naught, that is the radius of the hydrogen atom. And here we know for epsilon the value is 4 pi into 10 inverse 7, and the value of the h is 6.63 into 10 inverse 34, and the mass of the electron is 1.6 into 9.11 into 10 inverse 31, and charge of the electron is 1.6 into 10 inverse 19. And by putting all this value, we can calculate the value of orbital radius of hydrogen atom. Our next problem is if a spark from the electron in a hydrogen atom into an orbit where n is equal to 3, and for n equals, and what is the calculated energy in joule of the electron. And we know the equation E is equal to minus k z square divided by n square, and here k is a constant and the value is 2.179 into 10 inverse 18 joule. And here we put the value of n is equal to 3, and by putting this value in the equation, we can calculate the energy level, calculate the energy of that electron, and here the unit is in joule unit. And to convert from joule unit to electron volt, we can divide this value with the charge of electron, that is 1.6 into 10 inverse 19. By this way, you can change the unit of the unit from joule to electron volt. And another problem is find the second energy of the second Bohr orbital of hydrogen, and we have the equation that is E is equal to minus z kz square, and we know the value of the k is 2.179 into 10 inverse 18 joule, and the electron is characterized by n, and the value here the value of n is 2, cause the energy level is second, the orbital is second, and we are going to calculate the value of the second second energy level, or the energy of the second orbital. And by putting n is equal to 2 and z is equal to 1 and k is equal to 179 into 10 inverse 89, and value of the n is 2, and by putting all this value, and we have to put the value of z is equal to 1 here, and by putting all this value we can get the value of the second energy level, or the second Bohr orbital. Another problem is strontium 90 is a radioactive substance with a half-life of 28 days, and how many days will it take for a 200 gram sample of strontium 90 to be reduced to 8 grams. And we have equation that is n is equal to n naught half to the power t by t half, and by this equation we have the equation that is n is here, uh, that is ending substance quantity, and this is the initial quantity of the substance, and we have the equation that is that we see in our first slide, that is the equation is n equal to n naught half to the power t half over t over t half, and by putting all this below, and then we can take log in both side, and after that by taking log on both side, we can write that log 8 by 200 divided by log half is equal to t by 28, and here we have all this value, and by putting all this value in the calculator we can get the result of result that is t, the time taken to uh, taken to reduce the mass from 200 gram to 8 grams. And we have another problem. First, observe these. See the problem. In this problem, if an oncologist found a fossil sample that contains 25% carbon 14 in comparison to a living sample, the time of the fossil sample's death could be determined by rearranging equation 1. And here, since anti and not anti half are known, and we have the equation that is anti is equal to n naught half to the power t over t half, and we know the equation. From this equation we can write the equation as t is equal to t half ln anti by n naught divided by ln half ln 2, and by putting all this value, because we have similarly we have given values in the problem, and by putting all this value we can get the value of the time is 11460 year. This is the age of the fossil. And our next problem is a conceptual problem, and I suggest you to read the problem and try to solve by yourself. There are four conceptual problem is given for you to think about it, and you can pause the video here and try to solve all this conceptual problem, and you may take 2 to 3 minutes time in each problem, and pause the video here and try to solve 1 and 2, that is conceptual problem, and you take time. I'm going to our next problem, and these are the next two conceptual problem based on this chapter, and try to solve this conceptual problem also, and you can take 3 to 5 minutes time to solve its problems. And if you find any difficulties, then ask me in our class time. I'm going to our next slide, but you can pause the video here and try to solve this problem, and try to solve these problems too. And all the four problems given for you that are conceptual problem. And if you have any problem, then ask me in our class time. And here is a task is given for you, that is a radioactive substance has a half-life of 250 years. Determine the age of the substance. If it has retained 74% of its original amount. And here we have some information is given, and we have to calculate the time t, and half-life t half is given, that is 250 years, and retain amount, that is 74% of its initial amount is given. And by using all these given value, we can put it in a certain equation of t, and then we can solve this problem. I think all of you will be able to solve this problem. That's all for today, and this is the home task. And last but not least, I would like to suggest you to stay home, stay safe, and thank you for joining with us. Thank you. Allah Hafiz. Make the best use of your time.